for section 12.2, we're going to go over general angles, we're going to talk about radians, and then trig functions of any angle. So to start off, we are going to talk about angles in standard position. This is an example of what it looks like when we have an angle in standard position. It is always going to start with the initial side, and that's going to be on the positive x-axis. So every time your angle is going to start here. Then if you look, they have a curve drawn. This is part of your drawing. You need to include it every time. That will show us what angle you are referring to. The reason we want that is because there are technically two angles every time you draw an angle. There's the smaller angle, and then there's the larger angle going in the opposite direction. So without the arrow, we are not sure which angle measurement you are referring to. So again, make sure you draw that. Then your angle is going to end at what we call the terminal side. You will see that vocabulary word in some problems, so it is important you understand what that means. And one other thing that you will want to know is how to label your quadrants. So in a coordinate grid, it is split into 4 different parts that we call quadrants. We always start with quadrant 1, which is on the top right side. That is the quadrant that when people are learning to graph for the first time, that is where we always start. And then we expand the coordinate grid to include the other quadrants, and we label them going counterclockwise. So the top left is going to be quadrant 2, and when these are labeled, they're always labeled using Roman numerals. Then the one below that would be quadrant 3, and our last one would be quadrant 4. Okay. Our vertex is always at the origin, and then again, our initial side is where we start our angles. All right, so for example 1, they want us to draw an angle with the given measure in standard position, and then tell in which quadrant the terminal side lies in. This would be on a no calculator part of the test, so you would want to make sure you know how to do it without a calculator. So first we're going to start by drawing our coordinate grid. And it just has to be a sketch, so I'm not expecting you to have the degree angles exactly 100% correct. You just need to make sure they're in the correct quadrant, and then if they should be closer to the y-axis, make sure you're drawing it closer to that, or if it should be closer to the x-axis, you're drawing it closer to that part. So for this one, we always start with our terminal or our initial side, which is on the positive x-axis. And you do need to make sure you include that part of your angle. And if we're talking about degrees, when we go between two of the axes, that's going to be equal to 90 degrees. So that gives us 0 degrees, 90, 180, 270, and then 360 if we go all the way around. So this one we need to go 210 degrees. So I know that's going to be more than 180. And if I take 210 minus 180, that is going to give me 30 degrees. So I know I need to go 30 degrees past 180. So that's not going to be too far away. So that's where my terminal side is going to go, and I'm going to include my arrow and the curve indicating that's the angle I am talking about. All right, so that's our first example. That was a positive degree angle. When the angles are positive, we go counterclockwise. Our next example is a negative angle. So for this one, once we draw our x and our y axis, because it's negative, once we have our initial side drawn, we are going to go clockwise for this one. And I know 45 degrees is half of 90, so I'm going to draw this angle going right in the middle of quadrant 4. And then again, don't forget your curve to indicate what angle we are talking about. So we want it to go down. That shows us that it's a negative 45 degree angle. And one thing I forgot to do is we're supposed to label what quadrant the terminal side ends in. So if we go back to example A, we have quadrant 1, quadrant 2, and then quadrant 3, and that's where the terminal side is. So our answer here would be quadrant 3. Then if we go to example 2, again, we have quadrant 1, quadrant 2, quadrant 3, and that leaves us with our fourth quadrant where our angle ends, and that's where the terminal side is, so that is our answer. Okay, for this one, you might want to pause and try the last example on your own. All right, so hopefully you have your example drawn. For this one, we are again going to start with our initial side and our vertex at the origin. And we are going to, I'm going to label the degrees. So we know this is 90, 180, 270, and then 360. And it started at 0. So if we look, 510 is going to be making a full circle. So we know we're going to have to go past the circle once. And to figure out how much further we need to go past 360, we can take 510 minus 360. So 0 minus 0 is 0. I'm going to borrow from the 5 to make that 11 minus 6. And then 4 minus 3 is 1. So we need to go 150 degrees past 360. So that's going to put us in the second quadrant over here. When you are drawing your curve, you need to make sure you are indicating the whole angle of 510. So that means we're going to go all the way around the circle one full loop, because that's 360, and then we're going to draw a curve all the way to our terminal side, and that will show us the angle 510 degrees. If you were to draw only a curve from the initial side to the terminal side, that would not be the same angle, because that is only 150 degrees, which is smaller than 510. So the way you draw your curves also is a telling point of what angle we are working with. All right, so if you notice, the angle 150 and 510, they have the exact same terminal side, but they are different angle measurements. The vocabulary word for that is coterminal angles. So coterminal angles are angles where the terminal side, are in the same location. So if we look at our example C, we know that it ended in quadrant 2 and that 150 degrees is coterminal with 510 degrees, because again, they stopped in the same location. And if we look, the way that we found that is by adding 360 to 510. Or subtracting, or to 150, or subtracting 360 from 510. So the way that you can find coterminal angles is by adding and subtracting a full circle. And that leads us to our next part, example 2, which is find one positive angle and one negative angle that are coterminal with the given angles. This would be on the calculator part, so if you want to use a calculator to help you out with it, you sure can. So we are starting at 145 degrees. And if I want to go counterclockwise a full circle to end in that exact same spot, I'm just going to add 360. That will give me a coterminal angle of 505 degrees. Then that gives me a positive angle. I also need one negative angle. So to get to a negative, I'm going to start at the 145, but instead of adding, I'm going to subtract 360. And we'll see if that gets me a negative coterminal angle. And if you type that into your calculator, you would get negative 215 degrees. So that covers the requirements of a positive and a negative coterminal angle with 145. Okay, so then if you look at example B, this one we start at negative 395 degrees. So if I start like my last problem by adding 360, there we go, to get a coterminal angle, if I add those together, I get negative 35 degrees. So notice that's my negative angle that is coterminal. I also need a positive one. When you are looking for coterminal angles, it does not matter if you start with the initial angle they gave you or the coterminal angle you found when you decide to add or subtract 360. You will still end up with angles that are terminating in the same spot or are coterminal. So to get to a positive one, I already know if I take negative 395 plus 360, I don't get to a positive angle. I get to negative 35. So I'm going to take that negative 35 and I'm going to add another 360 so I can get to a positive angle. And when I take negative 35 plus 360, that will give me 325 degrees. Now we have the positive and the negative coterminal angles.